This video is on our new subtopic, but still under Boolean Algebra. So we're going to be deeper and deeper in our Boolean. Last time we already learned on the rules of a Boolean Algebra. Now we will implement all in how to simplify the Boolean Algebra expression. So you were given the examples over here. If you can see, this is the example, which is AB plus AB plus C, B factoring B plus C. So you're going to do the first step, which is distribute log to the red term. This is the red term, which is we're going to use the distribute law. So you're going to multiple AB, then multiple AC. Same goes to here, B multiple B, B multiple C. This is the first step. After you already make it longer like this, you're going to implement this green color to the A dot E over here, which is under rules number 7. Over here you get equal to B because B dot B, and you will get like this one. After that, step number 3, going to do the rules number 5, which is AB plus AB equal to AB. So you will be simplify the red color over here, and you will get this one. So that's why you need to remember all the 12 rules of Boolean algebra. But before you memorize this all, you need to have also the understanding. And then step number 4, you're going to apply into the green color, which is using quite similar, which is B plus BC equal to B. And lastly, you're going to apply this red color, B plus AB equal to B, similar also under rules number 10. And this long expression, you can simplify it to be AC plus B. So there is also another example on how to simplify the Boolean expression, but you can try it by yourself step by step. I think the problem with the simplifications of expressions like this one, and then you're going to simplify to this, is on your creativity and how you're going to apply all that 12 rules into this long expression. So you need to play around with which part that you can simplify, which part that you can make it longer, and then after longer, then you make it simplify back. So you can see one by one, step by step. So please try to do this exercise for B.2. If you can get it, then it's good for you. But if you still cannot get this answer, which is simplify the expression, so you must be try to do mini exercise from our previous subtopic. So there is 2 only on our form of Boolean expression. So you just need to remember SOP, which is currently needs to follow SOP and etc. So SOP and also POS. So what is SOP? SOP is sum of product, and POS is product of sum. So you can see over here, what is the difference is you use sum of the product. This is the product, which is ABC, and then use sum. But post of sum means that you sum it all, and then you to the product. So product term, a term with the product which is Boolean multiplication of literals, while sum term is a term with the sum Boolean additions of literal. So this is the standard form and also non-standard. How about standard? You can see that all, let's say over here we look into SOP, which is SOP A, B, C. There is also elements of A, B, C over here, although it is a bar, but this is still A elements. The bar is only represent as whether it is 0 or 1. And seen over here, you can see also the product here is having all the ABC. So this is the standard form, which means that you have all the variables in the products. You can see a standard SOP or POS form is when all variables appear in each product or sum term. You can see over here SOP means that you have a product and then you sum of product, which is you add all the product here. So this is one product, this is two product, and then this is three product. This is example. And then for POS, you will sum first and then you will product. Sum of which is your product and then sum. Product of sum for this one, right? So over here, one product, you have A, B, C, A, B, C, A, B, C. This is the standard form. But non-standard form, you can see that for SOP, we have, let's say, example here, AB, and then plus C, plus AB, A bar, B bar, C. So you can see that in this first product, there is no C variable. Please check again what is variables. And then AB over here, there is no C. For product number 2, there is no A and B. Product number 3, you have all elements, variables, which is A, B, C. For post over here, the example, you can see the first product, you have B and C only, but there is no A. And then another one is A plus C, there is no B. And then A plus B, but there is no C. So means that it's not full, having the full and all variables. So it's called as non-standard. So it's quite clear for you to differentiate whether this Boolean algebra expression, it is a standard form or non-standard. I repeat again, for standard form, have all variables in each product terms or sum term. Okay, sum of product or SOP. The bit of 0 is A bar, or maybe you can also have B bar, C bar, D bar, until Z bar. It is a 0 bit. But 1 is when you have A, B, C, D until Z. So product term, which is multiplication, you can see over here it's a dot. Sometimes it's just A, B, not putting the dot, but you need to know it is a multiplication. So let's say like this one, you have A, B. So as mentioned, it is equal to A dot B, isn't it? So after that, you will be, this one is a product term. So your product term will be a multiplications between A and B or AC or eitherwise, as long as basically you need to know between these two variables there is a dot or multiplication, and then the operation is summations, which is after you have a product, then you have another product, you will do the summations or adding, which is using this. You add all the product, then the output through table can map is 1. The symbol is like this one, so you need to remember sum of A, B, C, and then also P when two or more product term are summed. So basically if you have two product, then it's called as SOP, and if you have more than two, it's also called as SOP. So the minimum is when you have two product or more, then you sum, then it's called as a sum of product. So the example is like this one: A bar, B bar, C. This one is basically one product. So the example is like this: A bar dot B bar dot C bar. So this is one product under SOP, but this is one variable because basic. So this is not a good writing because this one still not yet simplify. You can still simplify it, although you can see, oh, this one is already simplified, but it is not. The good example writing is A bar, B bar, C bar. So you can see also over here the implementation of SOP expression. You have over here how you can see the expressions by having this non-standard, which is A, B, because there is no C, B and D. So over here non-standards because you don't have A over here, and this one you didn't have B and also D. It's okay. Then after that you can see that this is the simplest from the SOP expression. So you have a few exercises that provided. You can also try. I show you example. If let's say you are given A, B plus B, and then factoring C, D plus E, F, then you can make it like this, multiple, and this one. After that, after you done this part, you go into factorize this back, because you can see over here there is B for all of this factoring. So you can also have like this: A plus B, then B plus C plus D. Oh sorry, this one example number 2, because you have 3 examples. Until the first, so you have the solution for each exercise that given. So please try to do it, because this one is not yet simplified. You can still simplify, but this is just a simple exercise. So how you going to do it? And for SOP, this one you already looked into it on your SOP. Sorry, this one I think it's POS. So on POS, you can see that there is a difference on this, which is bit 1 is A bar, or B bar, C bar, star, and so on. So bit 1 is A bar and zeros for A. So it's quite different with S of P, which is, can see bit 0 is A bar, but POS is vice versa. So this is the simplest and the easy way how you can differentiate between SOP and also POS. Is it okay? Because it's quite simple. If you have uh, the question, let's say there is a question asking you on please write a differentiate table between SOP and also POS. You can just simply straightly write the differentiation on the input value. So the input value is the most easy to remember, and then next is the sum term, which is the additional. The operation is the multiplication, and another one is the output. K max is equal to 0. So this is another big difference that you can see. For the SOP, the kernel output is 1, but for POS it equal to 0. So easy for you to remember, isn't it? So the symbol is different also. So you can see there is another example, there is another difference. So please make sure that you remember the symbol for SOP and also POS. This is POS, and go back, this is for SOP, and this one is POS. So I make it slow so you can have a time to understand it. And for pause, when two or more sum terms are multiplied, you can see over here you have a sum and another sum, which is one sum and then two sum. So you have a multiply between this first sum and second sum, so you get the POS, product of sum. This is another example, and you can also have another example. As long as you have two, then enough. So this one is POS, and then the good writing is like this one, and this is another one which is you not yet simplified. So in this one, this is just the implementations of POS expressions, which is you have the basic one is O, after that you have and get. This is how post expression. And go back to the example of SOP. You can see here the SOP, you have and get, then you have the or get, which is and get, you multiple all the product and then you will sum or add all this product. But for the POS, we will add it first, adding process, which is you add A plus B, B plus C plus D. So this one is all adding, and after you add, then you will do a multiplication. It's easy to remember, right? So, and then after that, you look into standard of Boolean expressions. So this one you already know that you have SOP and also POS. But it's easy for you to remember and to do the simplification because normally SOP are referred to the rules number 6, and POS will always use the rule number 8 and 12. Normally they will use this. So a standard SOP or POS form is when all the variables appear in each product or also some. Which one? This one is we already looked into. This one is standard or non-standard. How it look like? There are two methods, which is SOP for each SOP and POS to solve the Boolean expression. So let's look into our first one, which is under SOP first. There is example like this: a factoring b plus cd, and then you get this a b plus a c d, which is non-standard. So non-standard because there is no c and d over here. This one there is no b. Then after that, what you need to do is you look into this example, which is standard SOP form when all the variables appear in each product. So because this is example, I think it's just a repeating just for you to remember. This is two example. You can see this is non-standard. This one also non-standard, but this is the standard SOP. You can have to convert the product term in standard SOP. You need this rule number 6. So what you're going to do is you're going to multiply each of non-standard term with the missing term using the Boolean algebra. So this is the rules number 6. Rule number 6 will be used on SOP. So you're going to repeat until all the variables appear in all the product term. So let's take a look into the example. You were given like this, which is non-standard. So what you're going to do is you need to do it to be a standard. So you will be apply the rules number before that. Okay, step by step. Okay, you're going to look into this one is term 1, term 2, and then term 3. For term 1, you miss the D, isn't it? And then for term 2, you miss the C and D, and then this one is full. So because of this, you miss D, so you need to apply the rules number 6. So what rules number 6 is you will put a plus a bar equal to 1. So if you have any numbers, you multiples it 1, so you still get 1, the value, you will get the same value. So let's say you pick this one, a b, I give you another example. Let's say you have a b, and then the complete variables will be a b c, but the first term you have a b, and then you need to multiply it with rules number 6. So you have like this. This is referred to 1. So if AB dot 1, which is you multiple it, you will get equations. It will be AB also, isn't it? Because this one is 1. So I repeat, A plus A bar equal to C. Sorry. A plus A bar equal to 1. So mean you will add over here any numbers and sorry, not any numbers, you will add over here any variable, not number, variables, as long as variable is not complete here. So let's say you need A, B, C as the standard SOP, but in the first term over here you missing the C. So you're going to multiple C and plus C bar because this is represent as 1. So you will get, if anything over here is 1, so you will remain get AB, isn't it? So similar, like let's say you have 17. Let's say this one A and B. Let's say give you example only, and then you need to multiple to 1. So you still get 17, isn't it? So any numbers over here, if you multiple with 1, you will get similar. So that's why you will multiple with this rule number 6 because it represents as 1. So go back to the example here. In first term, you are missing the D. So that's why you need to multiple it with D plus D bar, because D plus D bar is 1. 1 means that you just multiply it 1 and it's similar answer. That's why you will add like this, and then this one is A, B bar, C, multiple D plus D bar. So you will get A, B bar, C, D plus A, B bar, sorry, this one, no, and then D bar. So this is how you get the term 1. And then for term 2, you miss C and D. So what you're going to do is first you will multiple it with C plus C bar. Then you do it this first step. And then after that, you multiple it another with D plus D bar, because this one is represent as 1, and you need this second step because you still missing the D, isn't it? You still missing the D. That's why you will get like this one. After that, the term 3 is full of the variables, so no need to do anything. That's why you will get the answer as this one for the term 1. So it is like this. And then for term 2, you will get like this, 1, 2, 3, 4. And lastly, this one is similar to this one. So clear, right? Please do it step by step. And then there is also exercise on this. You can try to do it by yourself. If you don't understand, then you can ask me. Still, you can see that rules number 6 is very important for the SOP. After that, on simplifications, you need all rules. from 1 to 12, but it is for simplification. So what you need to know on sum of products, that bit 0 is A bar and bit 1 is A. So it depends on what is A and what is A bar. On this example, it mentions that identify a value that is missing in each term using a binary, so you know that binary only have 0 and 1. So let's say over here you have A, B bar, C, the term 1. So you miss D, isn't it? So you will multiply it with D plus D bar. So when you have this one, you have only two possibilities, which is 0 or 1, whether it is 0 to D bar and 1 to D. But if you are dealing with P or S, this 0 will be D. This one will be D bar. Get the difference right currently? So you already know the difference. Then this one and the miss term 2, you miss 4 possibility. You can have a look on that. So this is the truth table. A, B, C, D plus A, B bar, C, D, C bar, D, and then A bar, B bar, C bar, and also D bar. So you know basically that A represent as 1, B1, C1, D1, isn't it? And over here you have 1 and then 0. Why is 0? Because it's B bar. And then 1, over here you have all 0. So you know that all of this is a adding process. So after you have the summations or also adding process, what you're going to do is a not or get. So you have or get. You know also or get each possibility. Let's say you have at least one input having a value of 1, you will get the output as 1. So over here you will having like this. So this one is your output over here. So you will get output 1 if let's say the input is 0 0 0 0 and then 1 0 0 1 and also 1 1 1 1. So let's take a look. First one is this one 0 0 0. If you have 0 0 0 0, your F will be 1. And then you have 1 0 0 1. This is the part 1 0 0 1. So your output will be 1 also. And lastly 1 1 1 1. Over here you will get also the output 1. While for the POS, which is you have the standard variable appear in each sum term. So how you're going to convert product sum to the POS is using two rules. First rules is rules number 8. SOP what? Rules number 6. So pause rules number 8. So please remember that. And then after that, apply the rules number 12. So you're going to do repetitions of these rules number 8 and also 12 until all the variables appear in each term. So you have over here term 1, term 2 and also term 3. What you're going to do is you look into what is the lag over here. Is it on D, this one is A, and this one is full. So okay, so now over here, because this is POS, let me do something first. So over here you can see A equal to 0, B bar is 1, C bar is 1, this one is 0, this one is 1, 0. But you can draw like this, but because of this part, term 1 and term 2 is missing something. So what you need to do, you need to multiple first. So you will do A plus B bar, like this one. Sorry, just showing the rules first. A plus B bar plus C, you will add with D dot D bar, because you're missing D, right? And you have the rules number 8, A dot A bar is equal to 0. So you add any numbers over here, any numbers with 0, you will get similar answer because it doesn't affect you. So that's why you will get like this one. This is your first step. Second step, what you're going to do is using the rules number 12. So using a rules number 12, you have A plus B, C. You will get A plus B factoring A plus C. So rules number 20, A. Where is A over here? This one is term 2. So your term 2, you can see you missing the A. So you will do the adding for A dot A bar. So you will do like this first, which is using the 8, still under the rules number 8 over here. And then what you're going to do is you use the rules number 12. Rules number 12. So over here, where is A? Plus A, C. So you will do the A plus BC equal to A plus B factoring A plus C. So after you have here, you will do the factoring, which is this one and then this one. So what you're going to do is you add this one. Let me clear first. Apply the rules number 12. So you have A bar, this one and this one. So after that, you're going to do the A, B over here. This one is similar like this. And then over here, it will be a C. B bar, C, D bar. So this is the term for this one. Over here there is an exercise. You can try it by your own. Please make sure you use the rules number 8 first and then rules number 12 for your second step. So still under POS, you know basically A bar is 1, 0 is A. So you just need to fill in the value. Okay, because of this is POS. POS, you're going to get the sum of 0. Let me go to the slide. This one is sum of product. Where is POS? Okay, over here. You can see that the output will be a 0. Let's say you have A plus C. I just give you the example. Maybe this is D. This one is also D. I give you the example and please don't just simply believe that this is A and this is B or C or A or D. So I just want to show you if you have the products of sum or POS, you will get a output over here is a F which is 0. But for S or P, the output will be 1. So anything true between here, you will get 0 for POS and 1 for SOP. Go back to our slide. Okay, delete first. So you need to define the variables of SOP expression from these two simplest. Sorry, this one is of SOP. Oh, I forgot where is my slide. Okay. Wait, not yet reached. Okay, this is the exercise that you already done it. And go back to this slide over here. You know A bar it will be 1 and A equal to 0. So if let's say you are given this kind of expression, you will be having like this F equal to this one, and the value of F will be 0 if A is 0, 0, 0, 0, 0, 1, 1, 0, and then there is another 1, 1, 1, 1. After you have this kind of numbers, then you will get the solution like this. Let me check. The post expression equal to 0 when all the terms are 0. You can see the term. This is the term. This is the term. So when you have all the term is 0, then you will get the final output which is a 0 also. This is the truth table example. You because you're going to have this one 0 0 0 0, you will get the output as 0. 0 1 1 0, you will get the output as 0. Similar to this one 1 1 1 1, you will get the output of 0. Please try to do this exercise, quite simple. And after that, it is under SOP, standard converting, and last chapter is on Boolean expression and truth table. So all of this we're going to look into, all of this we're going to look into our next class. So I will just update on the e-learning if let's say I have another new video and also slide. So we just until here. Please try to do your exercise, and I will also upload extra exercise in your ebook. Thank you for your watching and have a nice day.